In part 2, we will continue our build of the TU8200 PC board 1, or unit 1 as they call it. We're going to start with mounting the 4 Zener diodes ZD1 through ZD4. Now these of course are used for voltage regulation. Just got to locate them on the board here. They are marked ZD1, ZD3, ZD4, and where is it? Where's the other one? Gotta find them. There's 3 of them, and oh, there's the other one over here, ZD2. So 1, ZD1, ZD2, ZD3, and ZD4. So the band on here, these are the little glass ones. The band is our cathode, and our band goes down with the cathode side here. It's marked with a K. That's the side that the band goes down on. So let's mount our 4 Zener diodes. Making sure that they're all mounted down firmly to the board. Just pull the leads up a bit, give them a bit of a bend, and then I will solder them down. Clean that iron off a bit. That's what good denim jeans are good for. Okay, that's the 4 Zener diodes mounted. Next we have the rectifier diodes. These are the black ones. There's 4 of them. They're marked D1, D2, D3, and D4. And they are going to go, where do these ones go? D4 is over here. D3. And where's 1 and 2? Well, let's mount 4 and 3 now that I've spotted those right away. Again, the band is the cathode, so that's this side here with the silver band on it. These are the ones with the black body. They're epoxy diodes. These are your rectifier type diodes, just standard silicon diodes. So let's mount 4 and 3, and then I'll find the other ones. While I'm doing that, I'll look for the other 2. Again, be careful when you're mounting these ones, because your polarity is important. If you put them in backwards, bad things are going to happen. So with diodes and electrolytic capacitors and transistors, polarity is important. So that's 3 and 4. Let's gotta find the location of 1 and 2. 1 is over here, and 2 is next to it. So, guys, you can see it here, but D1 and D2 go right over here. Next we have the bridge diode rectifiers, which are stuck into this piece of anti-static foam, so we'll leave them there until we're ready to mount them. We have D5, 6, and 7, so let's locate them on the board here. Here we go, D5, D6, and D7. These here are polarized, so you've got a positive and negative and 2 AC terminals here. And the components themselves actually are polarized as well. They're hard to see, but they go in this direction. Because on the top there's a positive and a negative pin, and there's the AC pins. So these go in just like that. And basically what these are is they're just 4 diodes. They're a bridge rectifier. So there's 4 diodes in each one of these little chip components. Dual inline package, they call them DIP. So we'll turn this over and solder these ones down to the board. I know the first video was actually quite a long video. I'm going to be making the remainder of these ones. I'm going to try and make them a lot shorter. I don't like going an hour long on a video and going on forever mounting parts, but I felt it was important to get all the resistors mounted on the other one. So on this video, I'm going to be making this one a little bit shorter and try and keep them to under 20 to 30 minutes tops, and then we can make a few more videos as the amp as the construction proceeds, but I'll try to make them a little bit shorter. Okay, next we have, there's two photocouplers. Yes, PC1 and PC2. So there are 2 photocouplers. One goes there and the other one goes over here. Those are the photocouplers that are on here, and again, these here are marked with a dot to indicate pin number 1. So the dot goes there and dot goes there. That's actually the anode from the photo transistor side, because, or sorry, a photodiode side. It's a cathode and anode of the LED, and then there's the collector and the emitter of the photo transistor. So the dot indicates the anode of the diode side. They go in like that. Now what these do, these are an optocoupler. What they do is they optically isolate typically high voltage from low voltage circuitry. They use them a lot in power supplies for the feedback circuit. They're used in all kinds of electronics where you need to isolate different power sources, and typically you're isolating high voltage from low voltage. How a optocoupler or photocoupler operates, for those that are unfamiliar with it, it's essentially a light source and a phototransistor. The earliest of optical couplers that I ever saw in person in the electronics business, RCA used to use them on some of their televisions to isolate the hot chassis from the remote control or the input switching. And how they did it, what they used it for was the power switch on a lot of televisions. And basically when you turned on the switch or used the remote control to turn on the television, it basically, the type of photocoupler that RCA used looked like, well, it was a cadmium sulfide photocell and a 12 volt incandescent light bulb. and they were sealed in a piece of heat shrink tubing about 1 inch long, with like a hollow tube in the middle so that it wouldn't shrink down on it. It's like a pen body, right? A little hollow tube about 1 inch long, and the photocell was on one side and the light bulb was on the other. Then they put a piece of heat shrink tubing over it like that, and they heat shrinked it down. And when you applied 12 volts to the light bulb would glow, and that would change the resistance on the photocell on the other side. Photocell resistance would go low. That's what they used as a way of isolation. It was really kind of hokey, but that's the earliest ones actually used an incandescent light. Then they perfected the combined LED and phototransistor, which is what these ones are. And basically, they're used a lot in power supplies for voltage regulation, for example, to, you know, with the collector and emitter side of the phototransistor on the oscillator for the high voltage, or for the hot side of the transformer, the oscillator, and the feedback loop was on the LED side. So the voltage went too high, the LED would shine brighter, which would change the frequency of the oscillator and bring the voltage down. And if the voltage was too low, the LED would go dim. That would cause the frequency to increase on the oscillator and bring up the voltage. And on this here, I'm sure, I haven't looked at the schematic, but I'm sure that this is in the automatic tube bias circuit, because this thing here will automatically bias the tubes. So if you stick different types of output tubes in, it can take out 4 or 5 different brands of tubes, different actual numbers of tubes that have totally different tube biasing. So this is what's used for the biasing. So there's our two ones, and now there's an IC here that goes in as well. Might as well install that while I'm at it. And that one is, where does it go here on the board? And it's right here. Yep. Again, it's, and this is also part of the tube bias circuit. So we just drop that little IC in. And pin 1 is marked with a dot. So the IC is in place. Now we'll solder that down as well. This looks to be a very well engineered little amplifier. And again, these solid state components that are on here have nothing to do with the sound quality itself. They're not involved in the actual amplification of the sound. It's more of a control to control the bias of the tubes. So that completes the IC. Let's go over to the next page here. Still got lots of assembly to do on this thing. And it looks like we've got an LED to install now. This is be the status LED, so I have to find it here. It's going to be in one of these bags of parts. Now this unit uses a tricolor LED. It's a red, green, and blue LED. How you determine the orientation to put this in is the cathode lead is slightly longer. If we look on it here, the third one over, looking from my right, be probably the third one over looking from camera left, I guess. Anyway, the longest lead is the cathode. You can also tell by looking at the little anvil inside the LED itself. If I can zoom the camera in here, I don't know if you're able to see it or not, or whether it's going to focus or not. But the anvil, the biggest part of the LED internally, that is the cathode, or what's also called the anvil. So they actually give you a little on the board here. You have to bend the leads at a right angle, and they actually give you a little lead bending tool. So it looks like we put the LED in here like that, and we bend the leads at a right angle. Kind of looks that way anyway. It looks like what they want us to do. They want us to put the LED up against this and use this as a template and bend the leads at a right angle. Like that. So now the leads can pop through the board. And we can solder it down. So there's our cathode, and our red, And when the LED is properly inserted, it actually fits in this little cutaway here on the board, as you can see here. So it sits in here in this space. So now we'll solder it down. It actually doesn't look like it's controlled by the circuit. It's just that it looks like you could put a jumper in, so you can either have it a red or blue or a green, or just maybe it's just a blue and green. The red is probably triggered by something else. Looks like the red is not going to a jumper, but red is going back to the side of the board. Yeah, red is connected back to circuitry, so red is always live, and then blue and green, either which one, you jumper it here, either for blue or green, to this common. So you can pick whether you want your operational color to be green or blue, but it'll go red if there's a fault. And I guess if you really want to be cool, you can jumper it so that the blue and the green light up at the same time, and then you'll have what blue and green give you cyan, I guess, a cyan colored light. I might just do that. Jumper the blue and the green so that I have a cyan colored power light instead of a blue or a green. Okay, that's that one done. What's next? Next, we've got a couple of transistors here, and they just happen to be, I believe, these ones right here. I got a couple transistors here. Looks like it's these ones. Let's just open up this bag. And that's what we got here. What's it say? Check the transistors. It would be Q1 A1266 or 1015 or A2SA 1015. What is the 1266? 2SA 1266. They're both the same transistors, so let's find Q1 and Q2. Q2 goes here. Q1 goes over here. They only go in one way. They're marked on the board which way to put them. Emitter collector base. It's nice because the leads are preformed, so I can just put them down on the board here and solder them in. So that's those two transistors. There's going to be the FETs go in next. So Q1 and 2, we'll check that off the list. We have a couple of FETs to go in right now. There's 3, 4, 5, and 6, so there's 4 FETs. I have them right here. Let's open up this bag. Okay, these ones are actually secured down to the board with nuts and screws. So I'm just looking for the right ones. Lots of screws for this thing. Lots of hardware. So there's still lots of assembly to go on this unit here, and that's another reason why I'm going to make it as a bunch of short videos, because there's still a lot to go. This is the first circuit board. There's like I think there's like 7 boards, although some of them are pretty small. But there's a lot of boards to go on here. Okay, let's mount down this. Let's mount down these FETs. This is caution, check the direction. Yeah, you think? Okay, where do they go? They go 1, 2, 3, 4. Here they are here. So we're going to bend the pins and install them on the board like that. So get my pliers out here to bend the pins over. And then we have to mount them and secure them down with screws and nuts and bolts. Put the 4 of them in. We'll secure them down with the mounting harder before we solder them as well. So there's our 4 installed. And we've got 4 screws to hold them down. And of course I just dropped 3 of them off the board when I did that, or 2 of them off the board. Secure that one down. Get the next one here. Give them a little bit of a torque down here. Put my stolen pliers from BCIT. Seriously, it says BCIT TV production department. I guess when I was going to BCIT, after class I must have been working in the lighting department or something, because we were working in a studio. And that's what I took in college, was television production. And I guess I put them in my pocket and forgot about them, and they came home with me and they never went back. I don't know. Someone from BCIT might be giving me a call saying, hey, we want our pliers back. Okay, if you want them back, come and get them. That was like 1980, I guess. Something like that, 81 maybe. I forget what year I went there. It was a long time ago. Okay, solder these ones down. That was back in the day when I thought I was going to be a big-time TV producer. And, well, I learned a lot, and I started my own production company, and I was fairly successful at that for years, but decided it was time to do something else. And, of course, I did the electronics gig as well, right? Because, well, anybody who's ever worked in video and film knows that, yeah, it's great when you're working, but you're not working every day. It's gigs come and go, right? So you're working on a gig for a while, and I ran my own company, and you know, it was up and down. There was days where there was times where we were really busy, and there was times where it was less busy, and that's when I did the TV repair business thing. That was my full-time gig, because that at least was that was constant income. Whereas the video production business, well, you got a good job, make a lot of money, you know, working on a music video, or which I did some of those, or a corporate video. You know, you're charging out $800 a day. Need you for half a day for, you know, a video shoot. Cameraman and camera goes for $400 for half a day. So, you know, there was it's good money to be made in it, but it wasn't steady work. Of course, they don't tell you that when they're taking your money when you're going to school, right? Okay, the FETs are mounted. Oh, now the vacuum tube. Now the vacuum tube sockets. They are right over. I think these are them here. We got 2 of them on this board. I think there's 2 of them on another board. But these will be the big ones. So let's just open up this bad boy. Everything comes in a hermetically sealed package. So there's 4 tube sockets in here. and this big ass capacitor. Look at that sucker. That one would give you a good bite. If that was charged, that would give you a really good bite. You see the voltage on that thing, eh? 180 microfarads at 420 volts. So yeah, that one would send you to the moon. Okay, we got some big sockets and some little tube sockets here, and I think they want me to mount the big tube sockets, it looks like. Actually, they want me to mount all of them. So let's get the tube sockets in. Here's the big ones. And the little ones. We've got a couple of 8-pin and a couple of 9-pin. And it says they go in on the other side of the board. So we turn the board over, and here's where our tube sockets go. V1, V2, V3, and V4. And of course, it says note the notch location, because these ones here, the tubes are all the way around. The pins are all the way around. So let's mount V1 and 2 to start with. I'm going to do these one at a time because I have a feeling if I turn them over, they're going to fall out. So we'll put in V1 first. Things starting to take shape, starting to look more like a tube amplifier now. That's what I mean. I knew that that was going to happen. They will fall out. One of them. The next one. I was just on one of my favorite vacuum tube sites, because I follow the tube forums quite regularly, being a big-time tube buff with my tube gear, and but I haven't been following that closely, and I was just noticing that Western Electric, I guess they came back a few years ago, but they're making tubes again in the States that are as good as the original 300Bs, and Northern Electric is back, and they were a Canadian manufacturer. They're actually not making their tubes in Canada. They're having them made for them, but they're being made by a very high-end boutique tube manufacturer, and they ship them back to Canada where they're fully burned in, and they're tested and evaluated before they give them the stamp of approval. So they're giving them very good ratings. So it's cool to see that the tube industry is doing quite well. You know, I've seen more and more tube amps, especially in my day job when I go into people's homes to work on other equipment that's there in my day job, which is no secret. I think a lot of people know what I do, but I work for an ISP and do IPTV work, installation and troubleshooting for IPTV, which is of course Internet Protocol TV and Internet and that type of stuff. Work with fiber optic and DSL and so forth on my day job. So I get to go into a lot of people's homes, and I get to see what cool stuff they've got. And you know, in the last 3 or 4 years, I started seeing an awful lot of tube gear coming back that I hadn't seen. I still see the home theater stuff, but I'm seeing more and more tube amps. You know, in the last couple of years, I've seen, you know, it's not a huge increase, but I'm certainly seeing a lot more now than I saw 10 years ago. Where 10 years ago, you might see one person out of you know, a couple hundred that have got a tube amp, and now I see tube amplifiers, you know, a couple times a week. definitely a couple times a month for sure, but I'm just seeing them on a more and more regular basis, which is kind of cool. It's the same with turntables, right? For a while there, we didn't see any vinyl at all, and now everywhere I turn, it's vinyl everywhere. Vinyl into a tube amp. That's the big one, and I see lots of it. So here's the last of the power tube sockets. Of course, this board, when it's installed in the case, it'll be installed upside down. Right, the tube's facing up, so all the components are mounted on the bottom side of the board. Next is a component called a PTC, or a positive temperature coefficient. It's a thermistor. Basically, it's this little device here. It's got an X10 marked on it, and it goes right down there where it's marked PTC. You can see the symbol on the board. These are not polarity specific, so you can mount them in any which way. And what this does is it's a thermistor. It sits up off the board and it monitors the temperature. And as the temperature changes, its resistance changes. And this would be to compensate for, you know, different ambient temperatures and temperature underneath the board. This will be on the bottom side, so basically what this thing is doing, because the board is going to be mounted in the cabinet like this. Tubes stick out the top. So the board's sitting in there like that. So as components heat up in here and produce heat, and as you get heat collecting in the bottom side, this is going to sense the temperature, and it's going to change its resistance. And by changing its resistance, it can do things like compensate, changing the bias or whatever it's doing, right? But it's to compensate for temperature. Also, a lot of times they'll use these as a soft start, so when you turn them on, the resistance will start out higher and then it'll go lower, or vice versa, so it gives you a soft start for your power supply. We have the film capacitors next. I just have to find them. C4 or C3 and 4 and 9 and 10, and they are 0.1 400 volt film capacitor, and I've got them somewhere in a bag here. Here we are. This is them. They've got a 104 label on them. 104, yeah, 400 volt, I believe that's what they are. They will be, they're 0.1, yeah, indicate they're 0.1 microfarad, 400 volt. It says they're brown. It doesn't look brown. That looks almost a reddish brown, but C3, 4, and 9, and 10 goes in here. C3, C4, C9, and C10. Here they go into the board here. And these are not polarity specific either, so they can go in either direction. It's only the electrolytics that are polarity specific. They're polarized. These are non-polarized. These are coupling capacitors, so we mount these down to the board nice and tight like that. I'm really quite surprised that they had me mount the tube sockets so early. You know, you would think that they would be the last thing to go on the board, because now there's a chance that they could get damaged with the soldering iron if I'm not careful. But hey, I'm just putting this thing together in the order that's on the plans. The whole point in this video is basically a teaching exercise for somebody who might want to build one of these units, so you can see how it's done. I got contacted by one of my viewers that saw part one, and looks like he might be wanting me to build him an amp. Contacted me by email. I'm not going to say any names here on the channel, but I got contacted by a viewer on email that asked me if I would be willing to put one of these together for him. He wants to see how this one turns out, but he asked me if I would be interested in doing one. I said sure, if the price is right. I'm not doing them for nothing, but you know, it's we can come to an arrangement, I may be building another one of these. Whether I doubt very much whether I'll build it on camera unless he specifically wants me to do that, because once we've done it once, there's really not a lot of point in doing it again, right? But hey, you never know. I certainly would be happy to put one of these things together if someone wants to make it worth my while. Okay, electrolytic capacitors now. These ones are polarized. So here we've got our electrolytics. Let's dig out all the electrolytics and start mounting these ones. I got a couple bags full of them here. So we'll just empty these bags out. And then we'll proceed to put all the wrong values in and put them all in backwards, right? Okay, 220 microfarads are the first ones. And that would be, I think these ones here, these are 220 at 16 volts, correct. C1. C2, well, these are all 220, so I got a whole bunch of 220s here. We'll just sort all the 220s out. There they all are. They're all 220 at 16 volts. So let's start mounting them. C1, C2, and C5 are the first ones. These will be easy to spot because, well, they're big. Here we go, C1. C1, C2, C5, and C6. So these are the ones that are right here in a row. There's 4 of them. So let's mount these 4. Double check the polarity before we solder them down too. And then C13 and 14 and 33, 34, and 35. So C13 and 14. Here's 13 over here. C14 is going to be over on the other side over here. We'll do those two. Put those two in place. C33, C40, 34, and C35 are the remaining ones here. It's the last 3 here. 33, 34, and 35 are right over here on the back side of the board here. That's got those ones down. And now we have to go to the 1 microfarad at 50 volts. So there's 3 of those, and that will be these little ones here. And those ones are C15 and 16 and 21. Just gonna find them. Okay, C16, here we go. C15 and 16, here's C16. And here's C21. And C15's got to be over on this other side, I'm thinking, and it is over here. C29 and 30 are 100 microfarad at 50 volts. So C29 and 30 go. Where are they going? Should be easier to find, right? Because their parts are less, but 29 and 30 are right over here at the back corner of the board. Okay, and 31 and 32, these are big ones. They're 3300 microfarad at only 10 volts, so I mean, these ones aren't going to kill you. 31 and 32 are right here. They're big ones, as I say. They're, oops, get the polarity correct. Of course, I'm sure you guys already knew this, but the white line here indicates negative, the negative terminal on the capacitor, and of course they're marked with a plus as well for the positive terminal. Positive terminal is the longer of the two leads, so it's pretty easy to get them in the right way, if you know what I mean. But people do put caps in backwards, that's for sure. It even happens from some of the manufacturers. A big time TV manufacturer got caught with capacitors that were put in backwards at the factory. Okay, now we've got some 10 microfarad at 400 volts. I gotta locate them. There's a bunch of them, so I gotta find them in my pile of parts. So now we're getting into the high voltage capacitors. C7, 8, 10, 11, or sorry, C7 and 8, 11 and 12, 23, 24, 25, 26, 27, and 28. It's going to be all these ones that are remaining. These are 10 microfarad at 400 volts. So let's start with C7 and C8, wherever they are hiding. There we go. C7 and C8 right here. Okay, and then C11 and 12. C11 is over here. It's going to be all these remaining electrolytic. C11 and C12 is over here. And 23 and 24. 25, 26, 27, and 28. Well, there's 27. And 28 is here. 26 is over here, and 25 just rolled away. And one last one, 25, shouldn't be hard to find. We're getting down to the wire as far as all the components that are on this board. I'm running out of things to put on this. This board is almost done as far as components go. Okay, we got the header that goes in there. It's an 8-pin header. It's obviously not polarized. It just says to insert the shorter side down to the board, which would be that way. And it only goes on one place, so solder that one down. Okay, that's the header. We've got a couple box connectors here to put on here. Gotta find them. And let's see here. Looks like there's a, it's called the VH connector, and then there's a couple of jumper plugs. Gotta find that connector. There's the jumper plugs. They're there, and this is, I guess, the box connectors they're talking about in this bag. And it looks like this one's got 6 pins. That would be this one, because the others are 2 and 4. And it is going to go CN9. It's going to go on like that. And of course we have to hold this one in place to solder it, because, well, the board's a little too, it's got components sticking up on it now that are higher than this, so it's going to fall out. So I'm just going to tack it in place one pin actually lines up right here on the end. There's a hole in the board that lines that pin up, so yeah, it'd be tough to put it in backwards. Plus the fact that the board is actually marked, it's silk screen, showing the outline of the connector and what way it goes in, so kind of tough to put it in backwards without really trying hard. Okay, that's got that one in place. Now there's a couple of J1, J2, and J3. That would be the jumpers for, I guess, setting the colors and so forth of the, I don't know, where does it say here? J1, J2. It says, okay, yes, CN9, I just installed that one. I got CN7 and CN8, which are the 4-pin ones. We'll get them installed now as well. So here's CN7 and CN8. These ones actually fit relatively tight, so they're not falling out like the other one was. And that's those three, and then I've got this J1, J2, and J3, which are these little red jumpers here. I just figure out where the heck they go. And it says, this is to select the output tube operation with the jumper plug. So I have a feeling that these ones here, these do not even solder in. There's two of them. Is there two of them? J1, J2. Oh, and J3 is for the power indication from blue and green. Green is recommended because it's brighter than blue. So that's what these are. These are not even soldered in. These are just plugged in, which is great because what I intend to do on this unit is I'm going to make up a series of switches. And what the switches are for is so that I'm able to select whether I want to have it in ultralinear or triode or pentrode. And these just plug in here onto the board like that. So you select which mode you're going to be in. And I guess they probably go through from the top. Yeah, they go through from the top on this thing. So you've got a ground, and you just plug those in like that. What I'm going to do is I'm going to set up a series of switches, and I'll cover that in one of the videos before I finish this project. But basically I'm going to have a series of switches, 2 switches, and I'll be able to switch between ultralinear, triode, and pentrode. And basically it'll just be 2 double pull, double throw switches that'll be connected. One switch will connect in one side, it'll connect to the triode, and the other side will switch to another switch which will select between pentrode and ultralinear or vice versa. Anyway, I'm going to cover that. That's going to be a modification that I do. I'll mount a little switch and we'll run those with some wires, but the jumpers are in now. This page finished. I think this board is pretty much all done. Oh, there's one more capacitor. I might as well mount the stupid thing now before I forget. Let's mount this big boy here. And I think, looking at this thing, that we have, I think that's it. I think that's all the components. So that will end part number 2. And then we'll pick up with part number 3 as we go forward and start to assemble some of the other boards and bring this project together. So I'll solder in the big capacitor and then say thanks for watching, and we'll catch you in part 3.